Well, friends, I regret to inform you that we must take yet another detour. While I was reviewing the code that we wrote in the last video, I noticed a logic error that we need to address. But rather than just go in there and fix it, I thought this would be a good opportunity to show you unit testing and why it's important. There's different software you can use for unit testing in Python. I personally prefer PyTest, but it doesn't come standard with Python, and unit test does. So for this tutorial, we're going to go ahead and use unit test. Now, before I write the actual unit tests, I'm going to write something called a context file. This isn't really standard. This is just a little trick I saw on the internet, and it happens to work great. The problem is you use the Python path to specify where your code is. And if we wrote unit tests and just did imports of the libraries that we want to unit test, we're going to end up with whatever is first in that path. So we might run tests against what's installed in the system and not what's in the repo that we're working on. And that's a problem. We want the unit tests to be executed against the code that we're modifying in our repo. So one strategy for doing that, and there's probably other ways to do it, but this one happens to work great, is you create a context file at the root where all the unit tests are going to be, and then all the unit tests will import that context. Now we're going to use two modules here, pathlib and sys. Pathlib contains the path object class, which is an object-oriented interface to paths, and it's awesome. I find it much easier to work with than OS path. So in Python, the Python path is represented by sys.path, and we want to insert, because we want it to be at the beginning, so we're going to say 0, and we want to put the repo directory that we're using at the beginning of that sys path. So in Python, under file will represent the current file that you're in. So we're going to create a path from that. And then we want the directory that this file is in and its parent directory, right? So that backs us up to that source directory. With the path object, you can just append a directory by using a /. Now all of this needs to be a string for the insert. So we'll cast it to string like that. And that should do it. Now if we import this context in our unit tests, that will make sure that the libraries we import will be from our repo and not from somewhere else in the system. And see, it found a problem. Bad white space. Now, that really wouldn't cause anything to fail, but there's no reason not to fix it. Good to go. Okay, so our unit test file name, we're going to test dictionary because that's the library that we want to write the unit tests against. I've got it up over here. Notice I'm using 3 windows. That's so that I can run the unit tests in one window. I can look at the code that I'm writing unit tests for in this window, and I can write the unit tests over here. In my experience, 3 windows is basically a necessary thing when you're writing unit tests. I'm also going to make this executable so I can run it directly. Ultimately, we don't want to run unit tests directly, and I'll show you that later in this video. But for now, I mean, when you're writing the individual unit tests, you want to be able to execute them individually, so go ahead and make it executable. Unit test is the module, and your unit test, if you're going to execute it, you want the if name equals main to call unit test.main, and that will execute any unit tests that you've defined in your file. Okay, remember I said we do the import context, and now if I import hangman.dictionary, I will guarantee this will come from that source directory in my repo. So all your unit tests in the unit test module has to inherit the unit test case object. And I know there's a lot to go over here. Each unit test, you may want to execute some code beforehand that's going to be the same for all the unit tests. And unit test has an option for that. It's called setup. It's case sensitive. It's not Pythonically named, right? There should be an underscore and a lowercase, but what can you do? And we're going to go ahead and create a dictionary instance variable that all the tests can use if they want to. All right. So the reason I have this window up over here is because as I go, I'm going to look to see what I want to write unit tests for. And one of the things I want to write unit tests for is this get method, right? I want to just go ahead and see if when I do a get, am I going to get dictionary words? Now they're going to be random and I need to do something about that, right? How do you test a random number? You can't because it's random. So I want to patch this randint call right here so that it always returns 0. That way I can predict what's going to be coming back from the index. So to do that, I'm going to need mock patch. So when you patch things, you're saying don't do the normal functionality, do what I tell you to do. And you want to try to patch where the actual code's coming from, right? You don't want to patch random.randint, so that patches it for everything. You want to patch Hangman's version of it, right? In the Hangman dictionary file, it imports randint, and that's what I want to mock. And I want to specify its return value should always be 0. Okay, I want to iterate through all of the potential words and see if they come back. So give me an index from 0 to the total number of words that there are. In Python, it's exclusive. So if the length is 7, it won't go to 7, it'll go 0 to 6. We're going to assert that it's equal. And this is why I did the setup, right? I can now reference this self dictionary, this instance variable in this function, even though I didn't create it. It's basically kind of like a constructor for this unit test or this group of unit tests. So the next one off the list should always be coming from that 0th element because I've patched the randint to always return a 0. All right, let's go ahead and run this and see if it works. Perhaps if I spelled dictionary correctly. Okay, now just because I have a passing unit test doesn't mean that I'm done. And one of the ways you can verify that you're not done is by using code coverage. Now I said before that ultimately we don't want to execute these unit tests manually. You want to use a tool called coverage and you want to run all the tests at the same time because sometimes they can conflict with one another. So the command for that is coverage, and then you do run-m, which is for module, unit test discover, and that will find all the unit tests in that directory and run them together. That allows me to run coverage report-m, which will show me all of the modules and what the amount of code coverage. So all code coverage means is what percentage of the lines are being executed when you run your unit tests. If you've got 100 lines in your module and your unit tests only execute 50 of those lines, your code coverage is 50%. In this case, we're looking at 92%, which is good, but it's not perfect. We're missing line number 19. Oh, so line number 19 is where we check to see if we're out of words. Note that test dictionary, the actual unit test itself, is showing up as not 100%. The reason for that is because when I'm running it using the unit test discover, this main code right here is not being run. It's never going to be. That's okay, but we don't want to have to see this 92% because that's really not accurate. The solution for that is to use a coverage RC file. Now it doesn't show up at 92% anymore. Well, let's go back here and see if we can write a unit test that tries to get this value error to raise. Let's see if we can exhaust the words. This time I don't have to worry about the random number coming back because I'm not trying to predict which word's coming back. I just want to say at some point I should run out of words. So I use a context manager. That's what this with is. It's called a context manager. I'm going to say that let's assume that this is going to raise and then execute my code. So whatever code comes in this block needs to actually cause that value error to get raised. All right, notice this underscore. In Python, sometimes you don't need variables. You're going to iterate, but you don't actually care what the value is. And if I were to do something like index, there's absolutely nothing wrong with that. But if I'm never going to use that index, pylint will trigger on that. And it's arguable whether or not that's a problem or not. In general, you shouldn't assign variables that you're never going to use. So it's really kind of a picky thing. And I wouldn't lose too much sleep over it. But if you want to use a variable name that represents a variable that you're never going to use, underscore or dummy are the two acceptable uses. And those are standard Python things. The interpreter itself doesn't know the difference, but that's the convention for the rest of the world, right? So pylint will acknowledge both dummy and underscore. So how about we iterate through the length of the dictionary plus 1. So we'll go 1 extra. That should take us outside that range. I don't care what's coming back, but at some point I should run out of words and I should get that value error. Let's see if that happens. Pop index out of range. I got an index error, not a value error. Why did that happen? Well, it's because I made a mistake in the last video. Right here. I should only be doing random numbers between 0 and the length of my list of words, not the original list of words, right? I am popping a value off of my list of words to make my list of words smaller. So I should only do a random number for my list of words. Okay, so I want self underscore words. That's my copy of words. Let's see if this one change has an impact. Again, it would if I spelled it correctly. Now my tests succeed. Now I know my code's good. I fixed my logic error. Let's see if our code coverage has improved. Okay, so we still are not at 100%. The reason this didn't show up before is if you were watching, and I'll show you, in that coverage RC file, I added this branch equals true. This says that when you're doing your code coverage, pay attention to see if all the branches are being used. In this case, it's saying, I'm not covering 12 going straight to 14. In other words, if this is false, am I going straight to here? And none of my tests do that because all of my unit tests are relying on this dictionary object that I created without an exclude list. If I want my unit tests to test this, I need to include a unit test for this. This is why code coverage is important. And if you take nothing else away from this, remember this. It's possible to write bad unit tests and be at 100%. It is impossible to write good unit tests and be at 50%. So you don't necessarily need complete coverage. You could have pretty good unit tests and only be 90%. There could be some of your code in there that's really not necessary to do testing on. But if you don't have a lot of code, I mean, code coverage is important. It tells you the things that you're missing. And in this case, we're not testing this code. We're not actually making sure that excluded words is doing anything. So the way we can test this is to look and see in our dictionary here where our first word is, aardvark, and exclude it and make sure that it doesn't come in. It's good to be descriptive in your unit test names. I'd like to give a shout out to Tyler Hers, who spent some time once trying to come up with a good standard for this. I don't know that we ever came to a final agreement on it, but he did some good work on that. Fix this while I'm here. So I can't rely on the setup version of it because I need to create my own dictionary this time that has excluded words. Okay, I will need to patch the randint to guarantee that I'm getting the first element back. But at this time I'm going to assert, oops. This time I'm going to assert that they're not equal. Get just the first one, which in this case should be not aardvark. All right, let's see if it passes. This is the spot where I needed to cut out about 2 minutes of me just staring at the code, trying to figure out why this didn't work before I realized that I used self dictionary when it should have been my dictionary. And let's see what our code coverage is. 100%. So now we have unit tests for our dictionary class and we fixed our logic error. I wanted to try to keep these videos short, so I'm going to stop here. The next video, I'm going to double back and write unit tests for the screen class. And then after that, we will get to the game class.